by looking at a couple examples here. Note we have 4 equations. We'll just start with the first one here. They're asking us to describe all of the different transformations, so all the different things that are happening to our parent function. Note that our first one here is a square root function, and underneath the radical I have a -7. Outside of the radical I have a +2. So what that +2 on the outside is telling me is that this whole graph is going to be shifted up 2 units. That's our k value. Stuff on the outside of our radical is represented with a k. So that's telling us we are moving up 2. Underneath the radical, that -7 helps us find our h value. If we jump back to that general form, keep in mind, h's are sort of the opposite of what you expect. We show that algebraically by putting a minus next to our h. So -7 isn't our h value, +7 is our h value. So that means that this whole thing is going to move to the right 7. It's the opposite of what we expect. Jumping over to the second example, number 2 here, now we have a cube root function, and it's added in something a bit extra. In addition to having a number on the outside, a k value, we also get a 4 in front that is multiplying by that cube root of x there. So we'll start with the -1 because that's something we've seen already. In the previous example, we were adding, so the graph moved up. In the second example here, that whole function is going to move down. Not 2 though, just 1. It's going to move down 1. In other words, k is -1. We could find the turning point for that graph. It would just have a y value of -1. This 4 out front causes us to go back to this table from the previous section. Note that that's a value bigger than 1. 4 is definitely bigger than 1, so this is going to be a stretch of 4. So we would have to stretch that whole graph vertically in order to take care of that 4 in front of the cube root. Number 3 adds in another interesting feature. There's a little negative sign on the outside of the function there, so we'll deal with that in a second. We also have a +3, now it's under the radical. So the +3 is an h value, or rather it helps us find the h value. Keep in mind those are the opposite of what we expect. So a +3 under the radical really means this graph will move to the left 3. H is actually a -3, not the +3 that we see there. This negative out front gives us a bit of information as well. If that a value is negative, note that then we get a reflection. So this negative sign outside of the radical tells us that this graph is reflected. In other words, points that would have been high on the parent graph will be low on this transformed graph. Points that were low will now be high. And last but not least, taking a look at number 4, this one has a little bit of everything. Got a -6 on the outside, a -2 underneath the radical, and then I also have this half that's sitting around out front. So the -6, that's a k value because it's outside of the radical. That's a vertical shift, and that's telling me that I need to move my graph down 6 units. -2 helps us find our k value because that one's under the radical. There's that sign flip. It's the opposite of what we expected. So this graph is going to move to the right 2. And then we also have this 1/2 out front. Going back to our table, when that value of a, when its absolute value is a fraction, it's something that's greater than 0 but less than 1, that tells us that we actually get a compression. This graph is going to be smooshed. So we want to be comfortable going between these graphs, these equations and their transformations, so that we can eventually make the graphs. We can start with a parent function and then do all of these different things to them. Move the graph up, down, left, or right. We can reflect or compress it, so on and so forth. The second couple problems here are asking us to go the other way. They're telling us a handful of transformations that they want done, and then we need to actually write the function. So let's start with function notation. And they're telling us that they want us to transform a square root. So I know that somewhere in here there's going to be a square root of x. There will be some other things that come into play, but at least we know there's a square root of x. So let's see what they want from us. They want us to reflect this graph across the x-axis. Just as a reminder, a reflection is caused by a negative a value. So I want there to be a negative outside of that radical. Let's keep going. They want us to shift 7 units to the left. So that allows us to find an h value. Keep in mind, left and right, they're sort of the opposite of what we expect. If we're shifting 7 units to the left, then that's a plus 7 underneath the radical. Those are the opposite of what we expect. And then last but not least, 1 unit down. That's a k value. That's a minus 1 on the outside of the radical. So that takes care of number 5. Number 6, again, we have a function, so we can start with function notation. If you're tired of calling the functions f, call them something else. G, h, q, whatever. We now have a cube root function. It's no longer a square root function, so keep track of that index. We know that we want this thing to be a cube root. Now they gave us the turning point, and instead of telling us exactly whether it's left, right, up, or down, they just gave us a couple of numbers to work with. So they gave us -2 and 3. Keep in mind, those are hk values. If we go back to our big table, h and k give us our turning point or end point if we're dealing with square roots. So while it doesn't seem like they gave us quite as much information as example 5, they gave us enough. So -2 is our h value. Keep in mind that's the one that goes under the radical, so it's the opposite of what we expect. So there's going to be a +2 underneath the radical. And then 3, that's our vertical shift. That's our k value. That's going to be a +3, but now it's on the outside of the radical. So go back, take a look at these 6 different examples using all the transformations information. The next thing we're going to do is actually graph some of these square root and cube root functions. So we want to make sure you're comfortable with getting all the transformations before we have to sit down and do any real work.